Okay, so in this video what we're going to do is we're going to have a look at some of the non-calculator topics. Now, when it comes to a non-calculator topic, this does not mean that it can't appear on a calculator paper, but there are quite a lot of topics that do not require you to use a calculator, and this makes them a little bit more likely to appear on a non-calculator paper. So what we're going to do in this video, we're going to have a look at all of those crossover topics, and by crossover I mean the topics that can appear on both the foundation and the higher exam, but they are lots of questions that do not require you to use a calculator, so they're great ones to be making sure that you revise before a non-calculator exam. Now, those of you that follow the channel a lot may recognise some of these questions because they are questions that I've used in individual videos in relation to each of these topics. So what I'm going to do is I'm going to link at each time what the topic is called and the specific video that relates to each topic, and that's going to be in the description for you, just to make sure that as you go through the video you know what the topic is called, and if it's something that you're unsure of, you will have a video there ready to do a full lesson on that. So do make sure that you check those out, but this should be a really good overview of a large collection of topics. Now, that does not mean that every single topic on the GCSE is here, and it also doesn't mean that certain other topics couldn't appear as well. So do make sure that you do your own subject analysis, and do make sure that you use the playlists within this channel to make sure that you check out all of the other topics. As well, if you are doing the higher exam, then I would strongly suggest that after you've looked through all of these and made sure that you are happy with them, you go and check out the grade 6 to 9 revision video, which again I will link at the top of the description in this video. But in regards to the non-calculator paper, do make sure, and the front of this exam paper is always really key to make sure that you read. The key bit here, obviously, in regards to this information, is it says here that you must show all of your working. Now, hopefully this goes without saying, but on a non-calculator paper, you do need to make sure that you write everything down, although the same can be said with the calculator paper. When you're doing the calculator paper, you are sort of less likely to write your working out down because you are doing it on the calculator, but it is essential even on a calculator paper to make sure that you write everything down. There are a huge amount of marks that you will gain just for your working out, so do make sure that no matter what the question says, you have a go at writing something down, even if you don't get to that final answer, because there are so many marks just for your working on a non-calculator paper. But there we go. That being said, obviously if you are preparing for a non-calculator exam at the moment, then obviously the best of luck to you, but please do make sure that you use every single resource possible, not just the videos on this channel, not just this one video, because there are lots and lots of topics that can come up. And again, I am going to go through the questions very quickly here with not as much explanation as you would need if it is a topic that you don't know, but this video works on the assumption that you've already done your revision. You're not using this as your only source of revision, but just as a nice little reminder, and maybe a topic will pop up within this video that you think, oh my god, I haven't actually seen that topic before, that's something that I need to revise. And then obviously you can go into the description and use that, and you know, hopefully that topic comes up in the exam and you'll have found something in the last moments that you maybe would have missed. Okay, but there we go, that's a little overview of what we're going to have a look at. So with that being said, let's get started. So write 180 as a product of prime factors and give your answer in index form. So we can do our nice little prime factor tree. And again, thinking of any two numbers that times to make 180. So I'm going to go for 18 and 10. 10 becomes 2 and 5, locking off those numbers when we see that they're prime. 18 is 2 and 9, and 9 is 3 and 3. And again, locking those all off when they're prime. Remembering you can write down some of the prime numbers if it helps. Now, writing these in size order, we get 2 times 2 times 3 times 3 times 5, and then we can simplify these. So 2 times 2 becomes 2 squared, 3 times 3 becomes times 3 squared, and then times 5 at the end, and that's in index form there using indices. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is. I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each, so that is one on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils, so that's 8 packs of pencils. 8 packs of pencils, and below there we have 1, 2, 3, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90, 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 doesn't, 8 doesn't, 9 does, 9 and 10. Now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18, we don't have to do all the factors of 72 there because we've spotted that it's 18. Of course we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3. And that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. Okay, so on the number line, show this inequality. So when we're drawing these sorts of things on a number line, we look at what numbers we've got. We're going to put our little circles above those, so -2 and 4. And we're going to join them up. And then we just need to have a look at these symbols. So the one here, which is less than or equal to, or pointing towards that less than or equal to, it has more ink on it, so we just remember to colour that one in. Make sure the circle has more ink in there as well. Nice little way of remembering it. There we go. So that is between -2 and 4. Remembering that is equal to -2. So the numbers that this could be is we could have -2, -1, 0, 1, 2, and 3, but not including the 4 there because it says less than 4. So you can have an inequality like this as well, where it just says x is greater than or equal to 1. So again, putting our circle above the 1, the greater than or equal to has the extra ink on it, so we'll colour that one in. It's equal to that as well, and greater than 1, so we'll just point an arrow to the right saying it's got to be greater than 1. And that's that for that type of inequality. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%. 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%. Dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, so a mobile phone is reduced by 20% in a sale. The sale price is £500, work out the original price. So this is a reverse percentage. It's asking us to work out the price in the past. Now I like to draw this in a slightly different way. I want to identify what percentage is this 500. So if it's been reduced by 20% in a sale, Well, that means that we have the 80% of the cost and this 20% reduction, if I think of this in terms of two little bars. So I've just got to think, which percentage actually is this 500? Is it the 80% or is it the 20%? Well, the sale price is the amount that we're paying, so not the little 20% sale. So that £500 equals 80%, and I always like to write this down. Now we don't want to know what 80% is, we want to know what 100% is. So I just need to think, how do I actually turn this back into 100%? So if we've got a calculator, this is nice and easy because we can divide that by 80, which will give us 1%. And if we do that on a calculator, 500 divided by 80 gives us £6.25. Okay, so 500 divided by 80. So if we have a calculator, we can do that. We can do 500 divided by 80. That tells us 1% is £6.25. And then we can times that by 100 to get 100%. And that would be 100% of what we're looking for equals £625. Oh, that's not a six, £625. Okay, if we don't have a calculator though, we're going to have to think of a different way of doing this. So what we can do is think about actually just dividing this by something to maybe get 10%. And you can divide 80 by 8 to get 10%. So if we divide 500 by 8, we'll also get 10%. And we can do that using a bit of a stop. So off to the side, if we didn't have a calculator, 8's into 500, 8's into 50 goes 48, so it would go in 6 times up to 48 with a remainder of 2. It would go into 20 twice up to 16 with a remainder of 4, so we'd have to carry that over. And then 8 goes into 45 times, so we get that 62.5 as 10%. So 10% is 62.5. And then we can times that by 10 to get back to 100%. And 100% there would be £625. So we get there either way, but that's two different ways of looking at a reverse percentage where we're looking for something in the past when there's a sale going on. Okay, so the other way around, a house rises in value by 3%. The value of the house increases by 7,500. Work out the value of the house before the increase. So when it's been increased in value, again, we can visualise this. We've got the original price, which is our 100%, and then it's rising in value by this extra little 3%. So again, identifying what is this 7,500? Is it the original 100% or is it the 3%? Now it says it rises, it increases by 7,500. So that 7,500 is my 3%. There you go, and again we want to know 100%. I can't straight away times 3 to get to 100, but I can divide both of these by 3 to find out what 1% is. And again, we can do that on a calculator or using better bus stop, but 7,500 divided by 3 is 2,500. So 2,500 equals 1. And again, we can times that by 100. So over here, if 1% equals 2,500, we can times that by 100 to get our 100%. So 100% will equal 2,500 with another 2 zeros, and that's 250,000. So our answer there would be £250,000. So £800 is invested for 2 years, offering a 1.5% simple interest rate per annum per year. How much is in the account after 2 years? Now, simple interest means it doesn't keep accumulating. So if we first work out what 1.5% is, again, if you haven't got a calculator, we can do this non-calculator. So 10% of 800 would be 80. 1% would therefore be 8, and 0.5%, which we're going to need there, is 4. So joining those two together, the 1 and the 1.5 gives us 12. So we get £12 there for our 1.5%. Now we can do this using a calculator as well, which I'll discuss in a sec, but if we're going to get £12 per year, simple interest just means that's what we're going to get per year. So if it's 2 years, we'll times that by 2, and we will get £24. So that's the amount of interest we'll earn. It does say how much is in the account though. So if we add that back into the account, we'd have £824 as our final answer. Now if you've got a calculator here, you can always use a multiplier method. So we could do 800 and we could times it by 1.015, and that gives us the answer 812, telling us that in that first year there we've earned £12 interest. So adding in another 12, so add another 12 would give us 824, the same answer. Okay, or you could times it by 0.015, and that would have just straight up given you the 12, and you can add that on for how many years for simple interest. Okay, so we're going to round these numbers to one significant figure. So 6.32 is going to round to 6, 6.51 rounds to 7, and then 0.503 to one significant figure on the bottom is 0.5. And whenever we've got these, we've got to work out what's on the top and what's on the bottom. So on the top there, 6 times 7 is 42, and it's 42 divided by 0.5. Obviously, if that was a nice little division there, we could do that straight away, but dividing by a half does something in particular. So dividing by a half actually doubles your answer. If you think half fits into 1 twice, so it'll fit into 42 84 times. So there we go, dividing by 0.5 doubles our number. Obviously if we had something like 3 on the bottom or something like that, that'd be a little easier, but dividing by 0.5 doubles our answer. So that's estimating. Just remember to round to one significant figure and then to complete your sums that way whenever you see that word estimate. Okay, so when it comes to compound interest, we could also have to do this without a calculator. So if we look at this one, it says James invests £4,000 for 2 years in a savings account and he was paid 3% compound interest per annum, and that compound interest there being the important word. It says how much interest did James earn in his savings account after 2 years? So how much interest as well is going to be important, and we'll address that at the end. So if he invests £4,000 for 2 years, we want to work out what he gets in year 1. So always split this up and make sure we keep it nice and organised, because we might potentially have to do 3 years, although that is a little bit harsh when we're doing this non-calculator. So if we work out 10% to start with, you can work out straight away 1%, but I always just like to go for 10% and break it down. So 10% of 4,000 is 400. Then we can go down to 1%, and you can feel free to go straight away for 1% if you're more comfortable with that. And then we can go for our 3%, which is going to be 3 lots of that 40, which is 120. So in the first year, James is going to earn £120, and if we add that back onto the 4,000, we'll have £4,120 at the start of year 2. So now if we move on to year 2, again we want to work out 10% of our new amount now, which is what makes compound interest different. We're going to work out 10% of 4,120. So this time 10% is going to be £412, just knocking that 0 off. Again, we can go for 1%, which now gives us £41.20, making sure that you introduce that 0 there because we are talking about money. And now we can get the 3%, which is going to be 3 lots of £41.20. Obviously without a calculator, feel free just to the side, and I would advise just to make sure you always write this working out down, but we just need to add together 3 of these. So if we add those all together, we get 60p over there, £3 and 4812, that's going to be £123.60. So £123.60, and if we add that onto our 4,120, we get £4,243.60. Now this question here does say how much interest did James get at the end of the 2 years. So we're actually only looking at the extra amount that he has over and above the 4,000. And we can see that we've now got 4,000 and the extra £243.60. So in terms of the interest that he got the extra £243 and 60p. So just make sure you're careful with the language of these questions. Just bear in mind they could be nasty and they could give you a 0.5% thrown into here, so it could be 3.5%, and if that is the case, it just means that we'd also, at this point when we found the 1%, we'd have to find a 0.5% as well, which would just be half of 1%, which would be 20, and we'd incorporate that there into our final percentage. Mary buys a car for £4,000. Each year it depreciates by 20%. Work out the value of the car in 3 years. So that word depreciate means it falls in value. Now again, with depreciation, it's similar to compound interest. It falls in value, but it falls in value based on its new price. So if we do this without a calculator, we can do it both ways. Year 1, the £4,000 is what it's worth. 20% of that we can work out. 10% is 400. 20% is 800. And if we take away that 800 there, so 4,000, take away 800, we end up with 3,200. So we don't keep losing £800 a year. Now in the second year, it's worth 3,200. 10% of that is 320. 20% of that is double that, 640. And we could subtract 640. So 3,200 take away 640. Will leave us with our answer for the final year. Take away 640 there, gives us 2,560. And we can finish this off, or I should have said year 2, we can finish this off on year 3. So our value is 2,560. 10% of that is 256, so 20% will be 512, and then we can subtract 512, so 2,560, take away 512, leaves us with a final value there of 2,048. £2,048, and that'd be our final answer. Again, we could do this with a calculator. If something loses 20% in value, then it's only actually worth 80% of its cost the previous year. So if it's worth 80%, the decimal that I can use for 80% is 0.8. If it's losing value, we won't want a 1 point number there, we've got 0.8. So we could just times it by 0.83 times, or times it by 0.8 to the power of 3. So I could just type into my calculator 4,000 times 0.8 to the power of 3, and I'll get that answer there, 2,048 as my final answer. And let's test that out. 4,000 times 0.8 to the power of 3, and we get 2,048. So that's depreciation. Okay, moving on to fractions, multiplying and dividing fractions. Multiplying fractions is the easiest one, isn't it? So we can times the top numbers, 3 times 2 is 6, and times the bottom numbers, 4 times 3 is 12. And we always want to simplify our answer, and a question will normally ask us to write it in its simplest form. So here we can divide the top and bottom by 6, and we get 1 over 2 as our final answer there. So always looking to simplify. On to the next one. We keep the first fraction the same, we flip the second one over, and we multiply them together. So times in the top numbers just like before, 2 times 5 is 10, 1 times 9 is 9, and again we'd normally be asked to write our answer in its simplest form or as a mixed number, and here it is an improper fraction. 9 fits into 10 once, with a remainder of 1/9 left over, so 1 and 1/9 would be my final answer there, and that's dividing fractions. When it comes to adding and subtracting, the process is the same. I'm just going to go for this one addition. So when we're doing this, we need to obviously look at the fact that there is a mixed number here, and we're going to make that into an improper fraction first, and that same goes for multiplying and dividing. So we're going to do 1 times the 4, the big number times the bottom, and then add the top. So 1 times 4, add the 3 is 7 quarters. And we're going to add to that this 2/3, and again, if that was a mixed number, we'd also convert that into an improper fraction. Now we need a common denominator when we're adding and subtracting, so that's going to be 12 on the bottom. So we can times this left fraction, top and bottom, by 3, and we can times this right fraction on the top and bottom by 4, and that's going to give us 2 fractions out of 12. So 7 on the left times 3 is 21 over 12, and on the right, 2 times 4 is 8 over 12. And now we can add these together, and again, if we were subtracting them, we'd just subtract those numerators now, but we'll add them together and we get 29 over 12. And again, it says to give your answer as a mixed number, so we are going to convert this now into a mixed number. 12 fits into 29 twice, up to 24, and there'll be a remainder of 5/12. And again, there's my final answer. Just be very, very careful at this point, just to have a look. Does this fraction simplify here, the little one? It doesn't, but let's imagine it was 4/12 there instead of 5/12. That would actually simplify, wouldn't it? Because if it was 4/12, we could divide the top and bottom by 4, and that would end up being 1/3. So just have a look in that situation. Does it simplify? This one obviously doesn't. It's 2 5/12. Let's have a look at another one. So in a bag of counters, 2/5 are blue, and it says 18 are blue. Work out the total number of counters in the bag. So it's not asking us to work out 2/5 of a number. It's saying that 2/5 are 18. Remember, it could have said work out 2/5 of, let's say, 20. And you divide by the bottom to get 1/5. You'd say that 1/5 is 4. And then times by the top to get 2/5, and we'd get 2/5 would be 8. That's a different question, so it's nothing to do with that. But it says 2/5 are blue and 18 are blue. So 2/5 equals 18. So if I want to work out 1/5 in this scenario, I need to divide by the top this time, because that gives me 1/5, half of that. So 1/5 would be 9. And then to work out 5/5, the original amount, we could times that by 5. So times it by 5, and we would get 5/5 equaling 45 counters. There you go, so that's our scenario there. So slightly different the other way around, obviously, to working out a fraction of an amount. It says that that fraction is 18. So dividing it by 2 to get 1/5, and then timesing it by 5 to get the original amount. Okay, so writing some numbers in standard form. We're going to make this a number between 1 and 10, times 10 to the power of however many jumps we have to do in whatever particular direction. So this number here, 5,600, I'm going to hop the decimal in between the 5 and the 6. So 1, 2, 3. So that becomes 5.6 times 10 to the power of, it's a big number there, it's not a 0 point number, so 10 to the power of 3. final answer. The next one is a small number, so we're going to have a negative power because we hopped the decimal the other way this time. So 1, 2, 3 would make it 3.4, and again this time it would be times 10 to the negative 3 because it's a 0 point number. That indicates that it's a small number. When it comes to the other way round, writing them as ordinary numbers, I like to rewrite this little bit at the start to start with. So 2 and 3, and I like to just imagine where that decimal is between the 2 and the 3. So times 10 to the power of 5 makes it a big number, so we need to hop it 5 places. 1, 2, 3, 4, 5 to the right, and then filling in all those zeros underneath. And if it is messy, just remember to rewrite that, but there's my answer, 230,000. The next one, 8.04 times 10 to the negative 3. So this is going to be a 0 point number, and again I'm just going to write these digits out at the start, these bits here, and imagine where the decimal is at the top, 8.04. So negative 3 means it's going to be a small number, so we're going to jump it left 3, 1, 1, 2, 3. So it's going to go there, fill in all the zeros and tidy it up at the start. So 0.00804, final answer. Okay, so write this as a power of 3. So when we've got the same base numbers, which we do, these are all 3s, we can add the powers when multiplying and subtract the powers when dividing. So if we tidy up the top to start with, which I always do first, we add the powers there because they're getting multiplied. So 3 to the power of 7, and on the bottom we've got 3 to the power of 3. Now these are being divided, so we can subtract the powers. So 7 take away 3 is 4, so we get 3 to the power of 4. And again, it doesn't say to work out the value of that, it says to leave it as a power of 3. If it said work out the value of it, I'd actually have to work that out, and that means 3 times 3 times 3 times 3. Wouldn't be very nice without a calculator, that one, but we could work it out. But it says to write as a power of 3. Okay, so negative and fractional powers. Remembering the negative symbol there just means to do the reciprocal, to flip it over. So in this first one, if that's 5 over 1 at the moment, it'll become 1 over 5. Now if it was just a negative 1 in the power, we'd leave it as it is because it could be a power of 1, but that 2 is just a normal power, which means we're going to have to square both of these. It's a normal squared power. So 1 squared on the top is 1, and 5 squared on the bottom is 25, and that's our final answer there. Onto a fractional power. Remembering that number on the bottom of the fraction represents a root. So in the case of a 2, that is a square root. So we're going to do the square root of 64, and the square root of 64 is 8. Now the 1 on the top is a normal power, so a normal power of 1 doesn't do anything. But if it was a 3, for example, we'd have to cube it, but it is just a 1. There's no negative in that one, so we don't have to flip it over or anything. It's just the square root, which gives us the answer 8. Okay, on to some combinations. It says in a bike store there are 8 different bikes and 10 different choices of paint colour. How many different combinations are there? Well, we have 8 choices of bikes to pick from, so that's 8 different combinations, and all we do is we multiply it by however many choices we have on the second option. So the second option is the paint colour, and there are 10, so we times it by 10 as our second option. So 8 times 10 gives us 80 options as our final answer. So you just take how many choices you have on each pick and multiply them together, and that's combinations. Okay, so this one's slightly different. A 3-digit padlock uses the numbers from 0 to 9. How many of the possible 3-digit number combinations use 3 different digits, meaning we can't have any repeats here? So let's imagine on the first one, on the first digit of this padlock, so imagine we've got 3 numbers. And on that first digit, let's say we pick the number 2. Now in that first pick there, we had the numbers from 0 to 9, including 0, so that would be 10 options that I had. But now that I've picked the number 2, I can't pick the number 2 again because there's no repeats. So I don't have 10 options now, I only have 9 options. Let's imagine we pick the number 3. So on this option now, on this third pick, I can't pick 2, I can't pick 3 out of these 10 numbers, so I only have 8 to choose from. So they are my 3-digit padlocks. Let's just imagine we pick the number 4, 2, 3, 4, and we'd have to multiply these all together. So 10 times 9 gives us 90. Well, we've got to times by 8, and 8 times 90, well 8 times 9 is 72. That's not a 7. 8 times 9 is 72. So 720, and that's how many different combinations we'd have for this particular padlock. So 10 times 9 times 8, perfect, 720. Okay, some error intervals. 6.4 has been rounded to 1 decimal place, and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to 1 decimal place, it couldn't have been 6.45. 5. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number, that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away. So it would be 6.35. Okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to 1 decimal place. On to the next one. This one's slightly different in the wording. So this one says it's been truncated to 1 decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5, because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So two different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well not forgetting there's a 1 in front of that, 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7, well 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below, we have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well 3 times 4 is 12, y times y is y squared, and then again copying that symbol as a negative. Expanding and simplifying two brackets, so we'll expand these separately. So let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Moving over to expanding and simplifying a double bracket. So x times x gives us x squared, x times negative 5 gives us negative 5x, 3 times x is positive 3x, and then positive 3 times negative 5 is negative 15. And then again, we just need to tidy this up because we've got these two x pieces in the middle. So we've got x squared still at the start, but we've got negative 5x add 3x, which in total is negative 2x, negative 5 add 3, and then we've got the negative 15 at the end. Onto the one below. So we've got some numbers in front of the x's here, so I'm going to do the same process. Let's see if we can move some of this out of the way. Just about. Okay, so 2x times 3x, 2 times 3 is 6, x times x is x squared, so we'll get 6x squared. 2x times 4 is 8x, that's negative 4, so it's negative 8x. Negative 3 times 3x is, well, 3 times 3 is 9, so negative 9x. And then negative 3 times negative 4 will give us positive 12. 3 times 4 is 12, and it's a negative times a negative. And then again, just tidying this up, we have 6x squared at the start, and we've got negative 8, take away another 9x. So negative 8, take away another 9x is negative 17x. And then we've got that plus 12 at the end, and there's our final answer. And we've simplified it there with the simplifying in the middle. Final answer. Okay, so factorising. We're going to take out a factor and put this into brackets. So we'll have a look at both these pieces. 3x and 15. We just think what number goes into both of those. They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus, and 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have two things, and let's have a look at both these pieces. So we've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? Well, we have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared, so I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that, and there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. We just need to have a look at these numbers there because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or minus 4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have plus 3 and plus 4, and that would make 7. So plus 3 and plus 4, and that's not a 4, plus 3 and plus 4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have two numbers in here with some symbols. So 28, the numbers at times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got minus 3 in the middle. So we want to make minus 3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16 or we could make 12. That's not going to work. But 4 and 7, we could do plus 4, take away 7. That'd make minus 3. So plus 4 and negative 7. And that's our double bracket there finished. So on to solving equations. So when we've got this word solve, it means it wants us to find the value of this x piece just here. So we've just got to reverse the process of what's going on. So at the moment it says 3 times the number, 3 times x plus 5 is 26. Well, if we get rid of this plus 5 by taking away 5 from both sides, that tells us that 3 times the number, 3x, must equal 21. And that means 3 times the number, so we can reverse this process now by dividing by 3, which I like to write as a little fraction, so divide by 3. And 21 divided by 3 is 7, so we would write x equals 7, and there's our final answer. So have a look at this next one. So 5x minus 2 equals 21. Well, this time to reverse this, we've got 5 times the number, take away 2, so if we add the 2 onto both sides, we get 5x equals 23. And here comes the part where I explain why I like to write it as a fraction as above rather than just writing divide by 3, because in this circumstance 23 doesn't divide perfectly by 5. So if we go divide by 5 again and divide by 5, we have our answer there written for us, 23 over 5. So x equals 23 over 5. Okay, which we could convert back into a mixed number. 5 goes in 4 times the remainder of 3. So we could write it's 4 with that remainder of 3/5 there. Or I could even write it as a decimal. I could type that into my calculator and turn it into a decimal, but it's fine to leave it as a fraction. 4 3/5 is my answer. So here's one where we've got x on both sides of the equation. So in order to make this look like one of the equations from before, we want to get rid of x from one of the sides. Now it doesn't matter which one we choose. I always choose to go for the smallest x. So we've got a 5x on one side and a 3x on the other side. So 3 being the smaller one. So we can take away 3x from both sides. That's smaller x. So if we take away 3x from both sides, well 5x take away 3x leaves us with 2x. We've still got that negative 3 there, and that now equals positive 9, so I won't bother putting the positive symbol. However, if there was a negative there, I would keep that in, just to emphasise that it is a negative 9, that's really important. So now we've got an equation just like the question before, so again we can add 3 to both sides, and we get 2x equals 12, and then we can divide that by 2. Again, I like writing that as a fraction, and 12 divided by 2 is 6, so we can write that as a whole number, x equals 6. Making x the subject of a formula, or any letter the subject of a formula. So this one's y equals 3x plus 5. So essentially, to make x a subject, we want it to say x equals. And we're going to rearrange these pieces and move them around, just like we did on that solving the equation. So the first thing I can do is I can get rid of that 5, just like before, and we can subtract 5 from both sides. Now I can't actually subtract 5 from y, so I'm just going to write that as y minus 5. And that now equals 3x. And just like before, we're just going to divide by 3. So if I divide by 3 both sides, thinking about how I did it before, I wrote it as a fraction like this, and that's what it's going to look like on the other side. It's going to be y minus 5 over 3 now equals x. 3x divided by 3 is just x. We've got x on its own. It doesn't matter that it's on the right hand side. We can rewrite it if we want. We can easily just rewrite x equals y minus 5 over 3, and there's our final answer. Got two slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5 equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there. But that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing I'm going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject. So we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted. So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket, so we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that. All we have to do is now multiply these. So 5 times 3 is 15. 2 lots of negative 2 is negative 4, and we're adding these together. So 15 add negative 4 is 11, remembering that these just become a takeaway, so it's 15 take away 4, so a would equal 11. There you go. Just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. Okay, so on to solving simultaneous equations. Now we've got two equations here. I'm going to call this one 1 and this one equation 2. Just so that I can talk about them. So when we're solving simultaneous equations, we want to make the coefficient, the number in front of one of the letters, the same. Now I always focus on this second one here, which in this case is the y. So on the top one we have 1y, and on the bottom one we have 3y. I know one of them is negative, but we'll deal with that later. I'm just purely looking at the number in front of it. So we have a 1y and we have a 3y. Now in order to make those numbers the same, I'm going to have to times the top one by 3, and that would make it a 3y. I don't have to times the bottom one by anything, but I might have to change them both in some of these questions. So let's have a look. If we multiply this top equation by 3, what does it become? So 4x would become 12x, the 1y becomes the 3y, and the number at the end will become 75. And that's my top equation. I'm going to rewrite the other one below it, which was 1x minus 3y equals 16. Now at this point I have the option, I can either add these two together or I can subtract them away from each other, but I want this 3y in the middle to get eliminated. Now if we think about the logics here, if I was to do 3y take away negative 3y, that would become a plus and I'd end up with 6y. So taking them away is not going to work, I'm going to have to add them together. 3y add negative 3y becomes 0. So if we add these two equations together, we get 13x equals 91. Okay, so there is a little way of remembering those. If those symbols there are different, you add them together, and if the signs are the same, you're going to subtract them. Okay, but here we are, we have 13x equals 91. If we divide both sides by 13, we get x equals 7. Now when it comes to simultaneous equations, we have to not just find the value of x, but we also have to find the value of y. So what I'm going to do is I'm going to sub x equals 7 into any of these equations that we've got written down. I'm just going to have a look at the start. I think this one's going to be the easier one for me, just because it's got a plus symbol. So if I sub x equals 7 into equation 1, I won't have that x there anymore, and we can start to work out what it is. So again, using brackets, I'm going to do 4 lots of 7, add that 1y, and that equals 25. Now 4 lots of 7 is 28, so we have 28 plus y equals 25. And again, we just need to now finish this off to solve it to find out what y is. Well, 28 add y is 25, it goes down, so it's got to be negative. If we solve this like normal, taking away 28 from both sides, we get y equals negative 3. And there's our final answer, y equals negative 3. So x equals 7 and y equals negative 3. I could have subbed this x equals 7 into any of the equations. I could have subbed it into equation 2. I could have even subbed it into this equation that we made up here if I wanted, but I think I just went for the easiest one there. So let's have a think. If I did sub it into equation 2, we'd have had 7 take away 3y equals 16. Doesn't quite seem as nice here, because now when we take away 7 we have negative 3y equals 9 when you take away 7, and then when you divide by negative 3, 9 divided by negative 3 is negative 3. So we could have solved it in that equation as well, but I've opted to go for the easier one there. Okay, so we've got some worded equations here. 3 calculators and 4 books cost £23, and 2 calculators and 3 books cost £16. Work out the price of a single calculator and a single book. So we have to create the equations ourselves here. So let's have a look. We've got 3 calculators and 4 books cost £23. Well, let's just call the calculator C, so 3C, and, so plus 4 books, let's call that B, equals 23, and we've got an equation there that looks similar to the last question. The next statement, we've got 2 calculators, so 2C, add 3 books, so 3B, equals 16. There we go, so we've got again an equation 1 and an equation 2. Now we've got to follow that same process as before. I'm going to make these numbers, these coefficients of b the same, but this time I'm going to have to change them both, because one's a 4, one's a 3. So let's think we could make those into 12, so I could times the top one by 3, and I could times the bottom one by 4, and that'd give me a 12 in the middle. So if we actually work that out, let's have a look, what do we get? Timesing the top one by 3, and let's move this around. Okay, so timesing the top one by 3, we get 9c plus 12b, and 23 times 3 is 69. Onto the one below, timesing them by 4, we have 8c plus 12b, and 16 times 4 is 64. Okay, so looking at these symbols, the signs are the same, they're both a plus, so the way to eliminate this 12b is to subtract these away from each other. So I'm going to do the bigger one on top, take away the smaller one on the bottom. So 9c, take away 8c, leaves us as 1c. And 69 take away 64 is 5. So straight away we get our answer there, c equals 5. So there's our first answer, c equals 5. And then we just need to sub that back into one of these equations. Again, I'm going to pick equation 1, I think. Let's have a look. We could do either one here, but I'm going to pick equation 1. So if c is 5, we have 3 lots of c, or 3 lots of 5. Add 4b, and that equals 23. There we go. Now 3 lots of 5 is 15, so we're going to have to take away 15 from both sides. And we get 4b equals 23, take away 15 is 8. And then dividing that by 4, we get b equals 2. There you go, 8 divided by 4, b equals 2. So our final answer there, we got c equals 5 and b equals 2. Obviously thinking about the context here, that was a calculator is £5 and a book is £2. So Adam, Brian and Chris are all work colleagues. Adam is 8 years older than Chris, Brian is twice as old as Adam. The sum of their ages is 92. How old are they all? Okay, so we can do this using equations as well. Now it says Adam is 8 years older than Chris and Brian is twice as old as Adam. Now it doesn't say anything about how much older Chris is than anyone else. So if let's call Chris X. Then what would Adam be? Now it says Adam is 8 years older than Chris, so Adam would be 8 older than that, exactly 8, so that would be whatever Chris's age is, X plus an extra 8. Then it says Brian is twice as old as Adam. Well, this is Adam here, X plus 8, so Brian is twice as old as that. So twice as old as that would be 2 lots of that, so 2 lots of X plus 8. And we could even expand that out now, so 2 lots of X plus 8 is 2X plus 16. So we have their 3 ages now in terms of algebra. We have Chris being X, Adam being X plus 8, and Brian being 2X plus 16. It says the sum of their ages is 92, so sum being to add them together. So if we add them all up and see what we get, we can have X plus the X plus 8 for Adam, plus the 2X plus 16 for Brian. And it says that they all equal 92. So if we start to simplify this, let's have a look. We've got x, x and 2x, which is 4x. And we have the 8 and the 16, which is 24. So 4x plus 24 equals 92. And now we can just solve this just like before. So I can take away 24 from both sides. Take away 4 is 88, take away 20 is 68. So we get 4x equals 68, and then we just need to divide by 4. So dividing that by 4, let's think, gives us 17. So x equals 17. So it does say how old are they all, so we could finish this off and we could just say, well, Chris was x, so Chris is 17. Adam was x plus 8, so Adam would be 17 plus 8, which is 25. And then Brian is twice as old as Adam, so Brian would be 50. Twice as old as 25, double 25. A nice little quick check there, you could just add those all up. 50 plus 25 is 75, plus the 17 is 92. So I'm happy that that works, it meets all those criteria. So the perimeter of the quadrilateral is double the perimeter of the triangle. Work out the perimeters. Now the lengths of each shape are given to us as expressions, so we could get an expression for each of the perimeters to start with. So let's have a look at that quadrilateral. Let's write that down over here. So the quadrilateral, we've got lots of pieces here, so let's count up these x's to start with. We've got 2x, plus this one's 4x, 7x, plus another one is 8x, so we have 8 x's. And the numbers, we've got a -3 and a -1, and in total that is -4. So that's the quadrilateral 8x minus 4, and that's an expression for the perimeter. Then we've got the triangle. Let's have a look what we've got there. We've got 1x, 2x, so 2x. And we've got 3, 4, 5, plus the 4 is 9, so 2x plus 9. Now it says the perimeter of the quadrilateral is double the perimeter of the triangle. So if we double the perimeter of the triangle, then that would be equal to the perimeter of the quadrilateral. Okay, so if we double this one, then those perimeters, those expressions for the perimeters would be equal. And if we double that, we get 4x plus 18. Now, because those two perimeters are now equal, we can set them equal to each other using an equation. So we can say this one here, the perimeter of the quadrilateral now, 8x minus 4, is equal to this one here, double the perimeter of the triangle. So that's equal to 4x plus 18. We can now just solve that like an equation, so we can get rid of the smaller x from both sides, so minus the 4x. So over here we have 4x, so we have 4x minus 4 equals 18. We can now add 4 to both sides, so get rid of this plus 4, so plus 4. And we get, let's do this over here, we get 4x equals 22. And then we've got to finish that off to find out the value of 1x, so dividing by 4, x will be 22 over 4, which is okay if we have a calculator, but 4 goes into 22 5 times with a remainder of 2, so it'll be 5 and 2 quarters, and 5 and 2 quarters is 5 and a half. So our final answer there, let's bring that up to here, would be 5 and a half, or 5.5. And again, it would have probably said in the question it was all in centimetres or it was all in metres, so we just have a look at what units we'd apply there, but 5.5 is our value of x. Now it says to work out the perimeter of the triangle, so we can sub these back in if we want. So 5.5 would be here in place of this one, would give us 8.5, so that would be 8.5. 5.5 on the x plus 2 here would give us 5.5 plus 2, which is 7.5, and then this one over here is 4. So if we add those all up, 8.5 plus 7.5 is 16, plus the 4 gives us a perimeter of 20 for the triangle. We could have done the same with the quadrilateral, but it said the quadrilateral is double the triangle, so this one here must be 40. And again, we could have just subbed that into the quadrilateral there and halved it for the triangle, but we've got our two perimeters. Again, just not forgetting what units it was, not that I've put any units in this one. Okay, so work out the size of angle ABC in this pentagon. So A to B to C is this angle here, and that's got a 2x in there at the moment. Now it's a pentagon, it doesn't say it's a regular pentagon, it's definitely not because all the angles are different. But we need to know what the angles are in a pentagon this time. So a triangle, remember, is 180. A quadrilateral, we add another 180, is 360. And then a 5-sided shape, we add another 180, which is 540. So 540 degrees is what these all add up to. Now if we add them all up, again, like we did before, we've got 2x, plus another one is 3x, plus another one is 4x. So we have 4x's, plus all these numbers. So we have 121, 112 and 15. And if we add those all up, 121, 112 and 15, we get 842 or 248. So plus 248 has to equal 540 degrees this time. And there's our equation made because we know all these angles have to add up to 540. So we've got slightly bigger numbers here, but let's take away 248. Take away 248 and it will tell us what those 4x's have to equal. So 540 take away 248 gives us 292. So 4x equals 292. And if we divide that by 4, it will tell us what the value of 1x is, and 1x comes out as 73 degrees. I'm not quite finished the question here because it does say if I work out the size of angle ABC. Now the size angle ABC here is 2x, so 2 lots of 73, 2 lots of x is 146 degrees. So that one there would be 146. Again, we could work out any of these, we would know that that one now is 73. And x plus 15 down the bottom here would be 73 plus 15, which would be 88. And if you add those all up, just to double check, you will get 540 degrees, but our final answer there is 146 degrees. Okay, so a nice quick one here, solving an inequality. Now this symbol shouldn't put you off here. It's an inequality, yes, but we're going to treat it exactly the same as if it was an equal sign. So before we saw a question like this where it was 2x plus 3 equals 20. We're going to do it in exactly the same way, but we're just going to leave that symbol in there. So we're going to take away 3 from both sides. which leaves us with 2x is less than 17, and then dividing by 2, we get x is less than 17 over 2, and we could probably work that out. 17 over 2, half of 17 is 8.5, so x is less than 8.5. So find an expression in terms of n for this sequence. So we're going to do the nth term, and then it says hence find the 50th term. So what I always like to do is draw these little loops just to see what times table this is related to, and from 3 to 7 it goes up by 4, and then it keeps going up by 4. So this is related to the 4 times table. Now the expression for the 4 times table is 4n, if we do it in terms of n. Now this is obviously not the 4 times table though, is it? Because the 4 times table, if I write it above, is 4, 8, 12, 16, 20. And all of these numbers are 1 less. Look, from 4 to 3 is -1, from 8 to 7 is -1, so it's the 4 times table, but it's had 1 taken away, and that is our nth term there in terms of n. There is also a little trick that you can apply on this. You can go backwards 4, so if we go back 4, we get the number -1, and that always tells us how much smaller or how much bigger it is than the times table we're looking at. So it says hence find the 50th term. Well, here's our little code, 4n minus 1. To find the 50th term in the 4 times table, you do 4 times 50, and it's no different for this one, but it's the 4 times table take away 1. So we're going to sub it in, and we get 4 times 50, or 4 lots of 50, but then we have to take away 1. 4 lots of 50 is 200, and 200 take away 1 gives us 199, and that is our 50th term. Just thinking, if you didn't have this nth term, you'd have to just keep counting up from 19, so you'd go 23, 27 and so on, and you'd have to keep counting up to the 50th term, and it'd take you quite a long time, so this is a nice little shortcut for that. Here's another one. Find an expression in terms of n for this sequence, and then will 84 be in this sequence? Explain your answer. Let's have a look. It's going up in 5s, so our expression for the 5 times table is 5n, but this is not the 5 times table because the 5 times tables goes 5, 10, 15, etc. So 6 is 1 bigger, 11 is 1 bigger, so it's the 5 times table, but it's got 1 added on, so that's my nth term this time again. We could have gone back 5, which would have given us the number 1, which is a positive one, and that's just another way that we could have a look at it. Now it says, will 84 be in this sequence? Explain your answer. Now, there's 2 different ways of doing this. This one in particular, I'd like to use more of a logical approach. So if you have a look at all these numbers, 6, 11, 16, 21, 26, they all end in 6 or 1. So I would be able to say no, because all the numbers end in 6 or 1. Okay, because they all end in 6 or 1. But there is another way of doing this. There we go, they all end in 6 or 1. Okay, so that's option 1. There is another way, because it might not be that there's a pattern, so my second option is I can actually just make an equation. I can just say, well, does 5n plus 1, does it ever equal 84? And that's what that means there. Does 5n plus 1 ever equal 84? And we can solve that. So taking away 1, we get 5n equals 83. And then if we divide by 5, we get 83 divided by 5, which is not a whole number. So I could say no, n's not going to be a whole number, the position is not going to be a whole number. Okay, so not a whole number. Now I'd obviously just have to make that statement, no, not a whole number. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now, there's 2 ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2 and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3, double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between minus 3 and 2. Now again, I'm going to do a little table for this. So we have x and y, and it's between minus 3 and 2. So minus 3, minus 2, minus 1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2, take away 3. I'm just going to work that out nice and slowly. 2 squared is 4 plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here, where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives, it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is negative 3. And here's where we need to be careful. So the first one here is negative 1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. Negative 1 squared, add 2 lots of negative 1, and then take away 3. Now the reason you have to put this in a calculator is because if you put negative 1 squared without the brackets, it will give you the answer negative 1. It will square the 1 and put the negative with it, rather than doing negative 1 times negative 1. Squaring a negative number makes it positive, so negative 1 squared is 1, add 2 times negative 1 is negative 2, and take away 3. So 1 take away 2 is negative 1, take away 3 is negative 4, so we get negative 4 for that one. There we go. Let's have a look at the next one. Negative 2 squared is 4. Add negative 4 is going to be 0. And then take away 3 gives us negative 3 again. And then onto the negative 3. Negative 3 squared is 9. Add 2 lots of that, so negative 6. So 9 take away 6 is 3. And then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that negative 4 in the middle, either side of that we've got negative 3. Either side of that we have 0. And then we have the additional 5 there. But let's just plot these and see what it looks like. So negative 3 to 0 is there. Negative 2 to negative 3 is there. Negative 1 to negative 4 is here. 0 to negative 3. 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets. And it tends to be that a cubic graph has this sort of shape. So just be careful. There are some others as well. We could have a reciprocal graph, where we have something like y equals 3 over x. And that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for two coordinates here. I've got one coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in ones, sometimes you might have 2 squares for every one, so just be careful of that. Now it goes across 1 and then it goes up 2. So it goes across 1 and up 2. So every 1 across it goes 2 up. So the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at -3. So c is going to be -3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through -3 on the y-intercept, and there's a gradient of 2 which I've found between those two whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'll take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick two coordinates. We've got one here and one here, and now this time for 1 across it goes 2 down. So 1 across it goes down 2. So my gradient this time is going down, and we'd say it's -2, so the gradient is -2. So y equals mx plus c, we have y equals -2x plus the positive one there for the y-intercept, and there's the equation of that line. And the last question on these, it says here are the equations of 3 straight lines. It says 2 of them are parallel, and explain which 2 are parallel. So in order for a line to be parallel, it's going in exactly the same direction, and therefore it has exactly the same gradient. So in terms of the equation of a line, which we always want in this form, y equals mx plus c, we want to see this number being exactly the same. So these are all written in different formats. None of them are in the form y equals mx plus c. So we need to actually get them into that form y equals mx plus c. So let's have a look at this first one. And that says 2y. So in order to get that to be just y, we're going to have to divide everything by 2. So if we divide everything by 2, we get 1y equals 3x, I'm going to do 6 divided by 2, and then 5 divided by 2 is 2.5, or I could just leave it as a fraction if I want 5 over 2, which you can write as 2.5 if you like. So this line here has a gradient of 3. Let's have a look at the next one. Y plus 3x equals 5. Well, that's not in the y equals mx plus c format either, because this 3x is on the wrong side of the equal sign. So if we take away 3x from both sides, move that over to the other side, we get y equals -3x plus 5, just popping that plus sign in front of that 5 there. Again, we could have written it the other way around, but let's keep them all aligned. So that is a gradient of -3. So those two definitely aren't parallel. Let's just have a look at this last one. So 3x minus y equals 5. Now this isn't very nice because we've got a negative y here on the left hand side. So I might have to do 2 steps here because I'm going to add y to both sides to make sure that that's positive. So at the moment we have 3x equals y plus 5, or 5 plus y. Let's write y plus 5. And then again we need to get rid of this 5 now because we don't want that there, so we need to move this 5 to the other side. So take away 5 and we get 3x plus 5 equals y. Now it's written the other way around there, but we can rewrite that. We can swap the sides over. So y equals 3x plus 5 is our final answer for that one. And again this one has a gradient of 3. So the top equation and the bottom equation both have a gradient of 3. So explaining which two are parallel, we would say line 1 and 3, as they both have a gradient of 3. And there we go, both have a gradient of 3. And that's that one finished. Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20. Which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. and it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them? So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far. Now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think, 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5, and there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. Ingredients to make 16 biscuits are 150 flour, 100 butter, 75 sugar and 12 grams of almonds. Alice has 140 grams of butter and is going to make enough biscuits for 24 people. Does she have enough? Well, whenever we're doing this, look, this is a recipe for 16 and we can start to break this down, particularly a non-calculator way here. If we want to get half of that, that's going to be 8. So half of all of those would be 75 grams of flour, be 50 grams of butter. It'd be not a very nice number here. 75 divided by 2 is 37.5 grams of sugar, and half of 12 is 6 grams of almonds. Now we could keep going. We could halve this again for a recipe for 4. We could halve it again for a recipe for 2. We could halve it again for a recipe for 1. Or we could have just divided all of these by 16 if we had a calculator to straight away get a recipe for 1. I'm going to assume this is a non-calculator though, but it says we want a recipe for 24 people. And if we have a look, 16 people, oh, didn't mean to erase that, there we go. So 16 people in this recipe and 8 people in this recipe. Well, in total, 16 plus 8 is 24 people. So if we combine these together, the recipe for 16, the recipe for 8, that'll give us a recipe for 24. So for 24 people, we can add these together. So 150 plus 75 is 225 grams of flour. 100 plus 50 is 150 grams of butter. 75 plus 37.5, not very nice one there, gives us 112.5. And 12 plus 6 gives us 18 grams for that last one. Now it says, we're actually only looking at the butter here, but I've gone ahead and done the whole recipe. But it says Alice has 140 grams of butter, and if we have a look, the actual amount of butter that we have, or we're going to need, is 150 grams. So if she only has 140 grams, we can say no. Okay, she needs 150. But there's a little process there for working out any sort of recipe there that we can make combinations of those smaller amounts of recipes. In a store, you can buy 2 kilograms of washing powder for £3.40 or 5 kilograms of washing powder for £7.20. Which size is best value for money? Now, there's two ways of doing this. I always like to split the page up. So we've got 2 kilograms or we've got the 5 kilograms. Okay, and the 2 kilograms is £3.40 and the 5 kilograms is £7.20. Now we can either build this up to the same amount of kilograms for each, so we could think actually, well, what if we bought 10 kilograms of each? Well, that would be 5 of these would be 10 kilograms, so if we times £3.40 by 5, we get £17. Or we can have 2 of these, and that would be £14 and 40 pence. And it's quite clear to see there that if we buy 10 kilograms of each, the 5 kilogram one is our cheaper option there. So we just make that statement, the 5 kilograms is cheaper. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0, so 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. And if we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams. And we want to know the cost of 1, so we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go, 1 jar is 250 and 1 tin of beans was 360. So a car has to travel 30 miles along a motorway in 24 minutes. Will the car have to travel faster than 70 miles an hour to get there in 24 minutes? Now I'm going to do this as a non-calculator one, then we'll have a look at one that's maybe a little bit more calculator based. But if it has to travel at 70 miles an hour or more, now 70 miles an hour means that we go 70 miles in 60 minutes. So 70 miles equals 60 minutes. Now what we can do is we can actually start to break this down. So if I have a look, what can I divide both sides by? So if I can divide both sides by 10, that would mean I would go 7 miles in 6 minutes. Okay, dividing that by 10 as well. So you can have a look to see if you can ever break these down this way. So 60 divided by 10 gives us 6 minutes. There we go. Now it says we've got to go 30 miles and we've got to go there in 24 minutes. Now just having a look at this speed here, 7 miles equals 6 minutes. So travelling at this speed, if I wanted to get to 24 minutes, have a look, 24 minutes, we would times that by 4. So if I do the same to the other side and times that by 4, that gives us 28 miles. So travelling at 70 miles an hour, in 24 minutes we would go 28 miles. And the question said a car has to travel 30 miles. So it's not actually going to be able to make that 30 miles in 24 minutes. It's only going to be able to go 28 miles. It would have to go over 70 miles an hour. So I would make obviously that statement no. Okay, it's only going to go 28 miles, or it's not going to be able to do it in that sort of speed. Or in other words, yes, it is going to have to travel faster than that 70 miles per hour. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time. And again, we can put that into a formula triangle if we want, and I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment we have, he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours, and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that would be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed, because we've got his total distance and his total time. The speed is distance over time, so it's 360 divided by the total time of 8 there, and 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. We've got some proportion here. 6 taps take 3 hours to fill a tank with water. How long will it take 9 taps to fill the same tank? And then we're going to state any assumptions that we've made. So if 6 taps take 3 hours, it will take 6 times as long as that for 1 tap. So 1 tap would take 3 times 6, which would be 18 hours. It takes 6 times longer. So 1 tap takes 18 hours. So from here, if we know how many taps we've got, we can just divide this 18 hours by however many taps. If we have 2 taps, we can divide it by 2, which would give us 9 hours. We could do 3 taps, divide it by 3 would give us 6 hours. But this particular question here said that there's 9 taps. How long would it take 9 taps? So if we do 18 hours divided by the 9 taps, it gives us a total answer of 2 hours. So these questions are all about working out first, how long would it take 1 tap, or whatever this question's actually about normally. So it says state any assumptions that you've made. Well, I've assumed here that all these taps are running at the same rate. Okay, that's my assumption. All taps run at the same rate. There we go. So obviously in that original statement there, 6 taps take 3 hours, while one of those taps might be running a lot faster than the other, and that would change our answer. So we are assuming that all the taps are running at the same rate. Okay, so working out the size of angle x. Again, I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110. And then next to the 110 on the straight line there, remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110, because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line, Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75 because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these two symbols here which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these two little, what I call little eyebrows. Okay, so underneath, this will also be 75 because base angles in an isosceles are equal. We can then find this missing angle here because angles in a triangle equal 180, so those two 75s equal 150, and if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now, to get that angle x, there's a couple of ways we could do it. We could find this angle here and then do angles on a straight line, or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30, so that's 30 degrees as well. So for this one, we'd say x equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. So working out the size of the angle between this regular octagon and regular hexagon. So there's different ways that you can approach this, but we need to know what the angles inside a hexagon all add up to and what the angles inside an octagon add up to. There's different ways of doing this. You can do the 180 list rule, so you can keep adding 180, so 3 sides is 180, 4 sides is 360, 5 sides is 540, and you can keep doing it this way, or you can apply a bit of a formula. So I'm going to go for the formula, even though I've started writing this down, but that is an option there that you can use. So for 6 sides in a hexagon, we take away 2, so 6 take away 2, which is 4, and then 4 times 180 tells us the total amount of, oh, that should be a times sign, let's change that. 4 times 180 gives us the total amount of angles in a hexagon, which is 720. So all the angles inside a hexagon equal 720, and there are 6 equal angles in there. So if we divide that by 6, 720 divided by 6 gives us 120 degrees. So all of these angles in the hexagon are 120. Obviously, we're concerned about this little area here in this question because we're trying to find the angle between them, but we've got the angle in the hexagon, and that's really important. When you see these words regular hexagon and regular octagon, always just work out the interior angle and label it all over the diagram. So moving on to the octagon, same process, 8 sides, take away 2 is 6, and then times that by 180. There you go, and 6 times 180, which is okay if you have a calculator. If not, you just have to work that out, but 6 times 180 is 1080. And again, it's got 8 equal angles, so if we divide that by 8, 1080 divided it by 8 gives us 135 degrees, and again, we can just label that all over the diagram. So 135, 135, and lots of these, but I'm concerned again with this little area here. So angles around a point equal 360, and at the moment we've got 2 of these angles, kind of like a jigsaw. So if we add these 2 together, 120 plus 135, at the moment we've got 255 degrees, and we need it to add up to 360. So to finish that off, if we do 360 and take away that 255 that we've just worked out there, we get a missing angle of 105 degrees, and that's our final answer there, 105 degrees, which we could always label on the diagram as well, 105. And there we go. So whenever you see these questions where it says regular octagon, regular hexagon, okay, just spot these bits of language here, just work out their interior angles and label it all over the diagram. Like working out the area of a trapezium, there's a formula for the area of a trapezium. It's a plus b over 2 times by the height. Or it can be written in a slightly different way. You can say half a plus b, again times in by the height. Now a and b are the parallel sides, which in this case is the 5 and the 9. So we add those together to start with, so 5 plus 9, we halve that, so 5 plus 9 is 14, half of it is 7, and then we times that by the height. Now you've just got to be careful here because you are given these 2 lengths on the side, and they're really there just to throw you. They're not the height, they're diagonal lengths. This 4 in the middle is what we want, the perpendicular height from the base, indicated by that red arrow there. So 4 is our height, so we're going to do 7 times 4, which gives us 28, and it is an area. It's in centimetres again, so centimetre squared. So just be careful with the trapezium there that you do identify the perpendicular height from the base. So we've got to work out the surface area of this cuboid. Now there's only 3 surfaces we can see. We've got this one on the front, but there's also one on the back that's exactly the same. back here that we can't see. We've got the one on the top, number 2, which is the same as the one on the bottom, and we've got this one on the side here, which is the same as this one that we can't see on the side. So if we work out the area of these 3 faces, we can just double our answer to get the ones on the back as well. So I'm going to do this in steps. I'm going to do the face number 1, which over here is 8 times 12. So 8 times 12 is 96 centimetres squared. Face number 2, the one on the top, we've got 14 along there, and it's not labelled, but this is 12 as well, the same as the bit below just down there. So that's 14 times 12. So 14 times 12, you've just got to work that out, and that's 168. So that's 168 centimetres squared. And then the last one, face number 3 on the side, it's not labelled, but we can label that the height's 8, and the length going backwards is 14, the same as on the length on the top there. So we've got 8 times 14. So 8 times 14 for our last one, 8 times 14 is 112. So that's 112 centimetres squared. And if we add all of these up, 112 plus 168 plus 96, we get the answer 376 centimetres squared. Now you've just got to be careful at this point, obviously don't forget there are 2 of each face, so we just need to double our answer or times that by 2. So times that by 2 gives us a total surface area here of 752 centimetres squared, and there's our final answer for the surface area. Working out the volume of a cuboid is quite nice and simple. I do like to do it in a particular way though, just so it's the same for all of these shapes where we have a constant cross section. So this cross section, I'm going to have a look at this front face just here. So I'm first going to just work out the area of that, which is 8 times 12. So 8 times 12 gives me 96, and that is the area of the cross section, 96 centimetres squared. And then to get the volume, we just times it by however far back the shape it goes, which is the same as that 14 back there. So times that by 14, 96 times 14 will give us our volume. So 96 times 14 is 1,344, and it's a volume, so we put centimetres cubed, and that's how you work out the volume there. That works for any shape. We've got a constant cross section. If you imagine, sometimes we have these triangular prisms, and sometimes we could even have a trapezium face prism there. Okay, anything with that constant cross section, you always work out the area of this front face to start with, the cross section, and times it by the distance it goes back. Okay, so we've got that these 2 shapes are mathematically similar. Work out the length of A and B. Now that there, mathematically similar, means one is an enlargement of the other, which means there's a scale factor between them. So if we can identify a similar side on both of them, which we've got here, 4 and 10, we can find the scale factor. So we always just do the big one divided by the little one. So 10 divided by 4, and 10 divided by 4, 4 fits in twice and a half, 4, 8, and then an extra 2, so it's 2.5. You might just get a whole number there, but there's my scale factor, and I always label that, I just say SF, so the scale factor is 2.5. So to get from a small one, let's have a look at A to start with. We've got to get from 7.5 back down to A. So that's going from the big shape down to the little one. So to get from the big one down to the little one, we divide by the scale factor. So divide by 2.5, and 7.5 divided by 2.5 will be 3 centimetres. And that's actually going to show the same for this other one here, look, because this one's 3 as well. But to get from 3 to B, we actually just times by that scale factor, so times by 2.5, and 3 times 2.5, which we already have there, is 7.5 centimetres. Okay, so you just got to remember, divide from the big to the small one, and then multiply by that scale factor to go from the small to the big one. But it's all about identifying that scale factor that we did up here, that 2.5. Here we go, working out some bearings. So write down the bearing of B from A. So if I'm at B and I want to go from A, then I'm standing over here at point A. Now there's 3 rules for bearings. They're always measured in a clockwise direction. There's always 3 digits. I always measure it from north. Okay, so they are my 3 bearing rules. So looking here, if I'm standing facing north, which is shown by the north line, I turn clockwise, I'd have to turn this full 60 degrees. So that thing there, 60 degrees, but it doesn't have 3 digits, so I stick a 0 in front of the 60. So it'd be 060 degrees, or 060 degrees. Now the next part of the question says write down the bearing of to A from B. So that means now I'm standing at B. So let's just get rid of these little bits. So this time A from B means I'm standing at B. Obviously, following these rules, if I face north, I've got to turn all the way around this way to get back to the direction of going back to A. So let's have a look at how we can do this. Now, what I quite like to do with these sorts of questions is to think about if I can extend the line slightly. So if I extend the line, because these two north lines are parallel, we've actually got a corresponding angle there. So this bit here is actually 60 degrees. So we can think about other angle rules while we're doing this. So from that bit just down to my little dotted line I've put in is 60 degrees. Now because this is a straight line, this extra bit here is an extra 180 degrees. So actually what I've got there is 60 to get me down to here, and then an extra 180. And if we add those together, 60 plus 180, we get a total of 240 degrees. So my answer for that would be 240 degrees, which does have 3 digits, so I can just leave it like that. Of course, there is another way that you can look at this as well. We could think about these two angles here as being co-interior that add up to 180. These two add up to 180. So this one here must have been 120. So actually I could take away 120 from 360, because that full turn there is 360 and we've got this little bit here as being 120, so I could actually do it like that as well. So there's two ways that we could approach it. Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is minus 2. Now negative 2 moves down towards the negative numbers. So 1, 2 down, and that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2, and there we go, we can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. And if you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well, though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point minus 1, 0. So first thing to do is obviously to locate that point, which is minus 1 across, not up and down, so minus 1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in, so trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees, so it would be facing this way and just making sure it stays nice and flat. And it would rotate the shape, let's have a look, it would go to here on your tracing paper, and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just said a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. Okay, so reading from a stem and leaf, it says the speed of 27 cars, work out the median and work out the range. So to work out the median, I want to know which one's in the middle. We can take quite a nice approach for this. We can just cross numbers off either side until we get to that middle number. So if there's 27, I'm going to cross off 10 from each side at least, so I can start to get from the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then going from the back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just going to do 1 from each side until I get one in the middle. So 1 and 1, 2 and 2, 3 and 3, and I'm left with this one here. Don't forget the key though, it says 3-8 or 3 line 8 means 38. So that's next to the 5, so it's 5 and 6, which is 56. So the median there would be 56. Working out the range, we want to look at which one's the smallest and which one's the biggest. Let's have a look. If I get rid of some of my lines here, the smallest number there is 38, the biggest is 70. So to work out the range, which I'll do up here, so the range will just be 70 the biggest, take away 38 the smallest, which is 32 as my range there. Again, there's median and range from a stem and leaf. Okay, so drawing a pie chart. We've got draw an accurate pie chart for this information. So the good thing about a pie chart is these numbers in the table are always going to fit into 360. This is quite a small one here, because if I add these up, I've only got 10 people in this pie chart. It looks like the type of fruit that they prefer maybe. So we've got 10 people, so all I want to figure out is how many times this fits into 360. So whatever that number adds up to, I can do 360 divided by that number, and it tells me that each person here represents 36 degrees. So all I want to do is times the amount of people by 36 in each scenario, we'll times them all by 36, and that will tell us the amount of the degrees I need to draw in my pie chart. So 2 times 36 is 72, 5 times 36 is 180, and 3 times 36 is 108. And again, it's quite a nice check here. If you add those up, they have to add up to 360. And if we add them up, let's have a look. 108 and 72 makes 180, plus the 180 is 360 degrees. So that's a nice little check there. You can tick that off, happy with that as 360. Now moving on to the next part, we actually have to draw the pie chart. So whatever kind of protractor you've got, you need to stick it over the top using this first line here as your starting line and measure out 72. Now if I guess where it's going to be about there. And all we need to do then is draw inside that piece of the pie what that represents. So that represented apple, and it represented 72 degrees. Then drawing in your banana there, which is 180, which is going to be a straight line going the other way. Again, measuring from this line as your new starting point, and that is going to be banana. Ooh. Banana, and that is 180 degrees. And then your final one there, because I've only got 3, the final one's done for me, although stick your protractor on and just make sure that this distance here is in fact the 108 degrees that we want, just to make sure you've done it all correctly. and you'll get an orange in there with 108 degrees. Now just remember, when it comes to a pie chart, if you ask to, then to compare this against another group, let's imagine we have another pie chart. I'm going to draw a really rubbishy one over here. We have another pie chart, and let's say that this size is apple now. So we've got apple, banana, and orange, and it says something along the lines of more people like apple in this pie chart. Now, without any numbers, we can't actually make any statements like that. So if you are given a pie chart to compare, just remember, without any numbers, you can't actually make a comparison, because there might only be 5 people in this pie chart, for example, in which case it might not necessarily be more people. Onto a scatter graph. It shows the time spent revising and the amount of mistakes made by 10 students in an exam. So state the coordinates of the outlier. Well, there's one point there which doesn't fall into the general pattern of this scatter graph, and it's this one just here. So I'll just state the coordinates there, and it's 4 below, and it goes up to 10, so I would say the coordinates are 4, 10 for that outlier just there. Now it says to describe the correlation. Now when it comes to a scatter graph, whether you're asked to or not, it's always a very good idea to draw in a line of best fit. So get your ruler, get your pencil, draw a nice straight line going in the general direction of the points. Now this particular one is going upwards, or it's sloping upwards, and we say that that has a positive correlation. Positive correlation. Stick in that word correlation there regardless of whether it's said. So positive correlation. The only other one is it could be sloping downwards in this sort of direction, and we would say it had a negative correlation. If there was no trend with the points, which is very unlikely on one of these questions, but if it's not sloping up or down, you'd have to say it had no correlation. And the final part of this question, it says, another student revises for 9 hours, estimate how many mistakes they'll made. So that's what we use this line of best fit for. So 9 hours is down here in between 8 and 10. So very, very carefully going up from 9, hit your line of best fit, and bounce off to the other side, and then as accurately as you can read that. On my screen it looks around 62, so I would say 62 marks as would be an estimate for the amount of mistakes that they would make. Okay, so they would get 62 marks. So actually, if it's out of 100, they would make 38 mistakes there. So just be careful what the question says. So they get 62 marks, which would be 38 mistakes. Okay. There we go, so 62 marks will be 38 mistakes. Okay, and the nicest of all the graphs is a frequency polygon, so really nice and easy to draw. All we do is we pick the midpoints in here and plot it against these numbers. So the midpoints, I'm just going to write them to the side. 25 is between 20 and 30, 35, 45, 55 and 65, and just plot them against these numbers here for the frequency. So 25 up to 8, as accurately as you can, is there. 35 up to 13 is here, 45 up to 25, so 45 to 25 is there, 55 to 10 is here, and the last one there, which is 65 to 4, is here. And then very carefully with a ruler and a pencil, from the first cross there to the last one, join them all up nice and carefully with a ruler and a pencil. Make sure it's not a curvy line, nice straight lines, and that's how you draw a frequency polygon. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment, we've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30, because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6. 5% is half of that, which is 3, and add them both together, and that's 9. Now part C here, you won't be given this at the same time as question B, because we already know that there are 60 counters in the bag, but it says that there are 12 red counters, and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, You could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up, so 60 counters there would be in the bag. Okay, so we've got a lot of information here. 100 students are in a year group, and then we've got some information about whether they wear or do not wear glasses. And it wants us to work out the probability of choosing a boy who wears glasses. And when you've got a lot of information like this, I like to organise it in a two-way table. So I'm going to put this all into a two-way table. Again, you could use a frequency tree, but I'm just going to opt for using a two-way table. So we could have boys and girls on the side. Again, you could have them at the top, but I'm going to put them to the side. And then you've got a total down the bottom. And then we've got whether they wear or do not wear glasses. And again, we've got a total here. So what I'm going to do is put the numbers within the question. We've got 100 students in the year group, 42 of them are boys, 8 out of 100 students wear glasses, so 8 students here wear glasses, and 52 of the girls do not wear glasses, so 52 just here. Now that's everything in the question, we've just got to fill in all the missing numbers now. So if there are 42 boys here, that must mean that there are 58 girls. And out of those, 52 do not wear glasses, so that must mean that 6 of them do. Now again, we've got 8 that do wear glasses, 6 of them are girls, so 2 boys must wear glasses. And again, going along this way, that has to add up to 42, so that must be 40. And then moving downwards or across from another direction, I could add those together to make 92. And a very quick check here, those two add up to 100, so that's right, we're happy with that, we can tick that off. Now it says, work out the probability of choosing a boy who wears glasses, and one of the students is picked at random. Well, 2 of the boys wear glasses, so that would be 2 students out of the 100 students that we've got here. You don't have to simplify that, but just a quick note, it could have said in the wording here, it could have said, rather than saying one of the students, it could have said one of the boys. Now if it had said it, maybe it had picked one of the boys, then that would have been out of 42, so it would have been 2 over 42. But it just depends on what the wording says, so it does say one of the students, it doesn't dictate whether it's boys or girls, so it's out of 100. I'm moving on to a Venn diagram. Now this symbol here just means all the numbers that we're going to put into the Venn diagram. So we've got the numbers 1 to 15, and then it says prime numbers and even numbers. Now what I'm going to do is I'm going to write down the prime numbers to start with. So we have 2, 3, 5, 7, 11 and 13. And we could write down all the even numbers as well, but I'm hoping we can recognise them quite easily. Now what I'm going to have a look at is which numbers are in both. Now the only even number in that prime list is the 2. So that's going to go in the middle because that says it's in both. So I'm going to cross the 2 off and cross it off from my main list. It then says, obviously we've got the prime numbers in set S, so I need to put all the rest into set S, so 3, 5, 7, 11, 13. Again, I'm going to cross them all off from my main list, so 3, 5, 7, 11, 13, and then all the even numbers are going to go in the right circle there. So we've already got rid of 2, so 4, 6, 8, 10, 12, 14, and again just crossing those all off from the main list. So 4, 6, 8, 10, 12, 14, and the remaining numbers there are going to go around the outside. So I've got 1, cross that off, stick it on the outside, 9, cross it off, stick it on the outside, and 15, cross that off and stick it on the outside. Now we're asked some questions about the Venn diagram. It says list the members of SUE. Now that U stands for the union, and the union is everything within the circles. So that's the members of S, the members of E, and that number in the middle there. So if I write them all down, all the numbers there for part B are, from left to right, we've got 5, 11, 7, 3, 13, 2, and then all those even numbers, 4, 6, 8, 10, 12, and 14. Let's have a look at part C. Write down P, SNE. Now that P at the start there just stands for probability, so write down the probability that it's in SNE. Now that N is a different symbol again, and the N stands for the intersection. So this is asking me, what's the probability of picking the number that's in the intersection? Now in the intersection, we only have this number 2. So there's one number, so for that part C there, I'd say one number out of, because it's a probability, and there are 15 numbers in total. So the probability there would be 1 out of 15 for part C. Again, it could say SUE, and that would have been, again, we've got to count all the numbers in the union. Let's have a look, there's 3, 6, 9, 12 numbers there, so that would be 12 out of 15. Now the final part here, it says find the probability a number is in set E dash, and that little dash just means not in. So E dash means not in E. So E dash, not in E. Now if we have a look, there are quite a few numbers that are in E. So all of these numbers here are in E. So all we need to do is have a look at how many numbers are not in E. So let's pick a different colour. Let's underline all the numbers that are not in E. 1, 2, 3, 4, 5, 6, 7, 8. So the probability of picking a number that's not in E is 8, again out of 15. So again, just remember that the little dash means not in that set, the N means the intersection where they cross over, and the U stands for the union, which is all the numbers within all of the circles. Okay, so the probability that Amy wins a game of snooker is 0.2. Amy's going to play 2 games of snooker, work out the probability she wins exactly 1 game. Now let's have a look at this one. So if we create a probability tree for this, we've got on that first game, which I'll label this branch as the first, she either wins or she loses. And the probability she wins is 0.2 and the probability that she loses is 0.8. Now she's going to play a second game, so I'm going to have a second branch. Again, this is after she's won, and we've got a second branch here in case she loses. But again, she wins or she loses, and she wins or she loses. Now it doesn't say the probability changes on the second game, so it's all just going to be the same. 0.2 for a win, 0.8 for a loss, and the same below. 0.2 for a win, 0.8 for a loss. Okay. So it says work out the probability she wins exactly 1 game. So she wins exactly 1 game, that's quite important there. Now the only way that she wins exactly 1 game is if she also loses a game. So this win-win up here is no good, and this lose-lose down here is no good. But here we've got the probability of a win and then a loss, and then here we've got the probability of a loss and then a win. All we need to do is work out these 2 probabilities. So to get to this second branch here, if we go to the start, we go up through the win and down through the loss. So that's 0.2 multiplied by 0.8. And 0.2 times 0.8 is 0.16. Looking at the second option there, she could lose and then win. And that just goes through 0.8 multiplied by 0.2, which gives us the same answer there of 0.16. So we've got our 2 answers there. We've got 0.16 for that route and 0.16 for that route, and when we've got 2 probabilities to combine, we just add them both together. So 0.16 add 0.16 gives us a total probability there of 0.32 as our final answer. So another probability question. James takes the bus to school. The probability his bus is late going to school is 0.3, and the probability his bus is late going home is 0.7. What is the probability that at least one of his buses is late? Let's have a look at creating a tree. So this time it's not the same thing on both occasions. We've got one where he's going to school, and the other part of the branch is where he's going home. But when he goes to school, it's either late or it's not late. And the probability of late is 0.3, so therefore the probability that it's not late is 0.7. Then we've got the next branch, which is going home. Now the numbers look quite similar here because we've got 0.7 in there again, but we've got late and not late, and again late and not late. But this time it says going home, the probability that's late is 0.7, so this would be 0.7, and again 0.3, and the same below, so 0.7 and 0.3. Now the question says to work out the probability that at least one of his buses is late. So this time it's not just one late, it could be late on both. So we could have the probability, let's do this in a different colour, we could have the probability that it is late and then late. We could have the probability that it is late and then not late, that's at least one, and the probability that it is not late and then late on the second one. But not late on both is no good to us, so we don't want that one. So what we need to do is work out these 3 probabilities this time. So late then late goes through 0.3 and then 0.7, which is 0.21. We've got the probability of it being late then not late, which is 0.3 times another 0.3, which is 0.09. And we've got that third one there, okay, which is not late and then late, which is 0.7 times 0.7, and that equals 0.49. So this time we've got 3 probabilities to add together, but because we've got a combination there, again, we just add them all up. So 0.21, 0.09, and 0.49. And altogether that adds up to, let's have a look, 8, 9, carry the 1, 4, 5, 6, 7, so 0.79 is our final answer for this one. Let's have a look at some with some fractions. Okay, so the hardest one out of the bunch here, we've got 4 red counters and 5 blue counters. One counter is taken and not replaced, and then a second counter is taken from the bag. Work out the probability that both are red. Now this piece of language here is important, taken and not replaced. So that's going to give us two options here when we do our tree, but let's have a look at the first option. So initially we've got red or blue. This is our first pick. And the red counters, there are 4 out of a total of 9. And the blue, there are 5 out of a total of 9. Now let's just have a look at this second pick to start with, and let's imagine we took a red. So if we take a red, what have we got now? We've got 3 reds left in the bag, and there are only 8 counters in total. But none of the blues were taken, so we still have 5, and that balances out to 8 there on the bottom, so we've got that option there. Now, because this is going to be different, taken and not replaced, the second part of the tree is now going to be different, because if we go back to the start here, we've now got to imagine, okay, well, what happens if we took a blue? Well, we still have the option of taking a red or a blue, but this time the blue has been reduced to 4, so still out of 8 now, but it's going to be 4 for blue, and balancing that out, there's still 4 reds in the bag. So we've got 4 out of 8 this time for the reds. Now we've got an easier question for this one because it says work out the probability that both counters are red. Now that gives us only the option of having this branch here, the probability of a red and then a red. And to get that root there, we just go through red on the first root and red on the second root. And that gives us 4/9. And again we multiply by 3/8. Times in the top gives us 12 and times in the bottom gives us 72. So our final answer there would be 12 out of 72. Again though, if we were asked different questions, we would work out multiple roots and we would add them together. All the fractions here are going to be out of 72 because the denominators are always going to be 9 times 8. So our fractions are going to be nice and easy to add together. If we imagine that it said probability of getting 2 reds or 2 blues, the probability of 2 blues down here would be 5 times 4, 20 over 72, and that's nice and easy to add to 12 over 72 because you just add those numerators together. But it's the same process, multiplying across the tree and then adding to combine any probabilities at the end. Now there are a few non-calculator questions, and again there's more of these on the higher, but 2 here that we really need to know, and that is sine 30 and cos 60. Now the value of sine 30 is 1/2. As is the value of cos 60. So they're both equal 1/2, and they're really good ones to make sure that you know for these non-calculator papers. Okay, so do remember those ones, sine 30 and cos 60, and they're both equal 1/2. And let's see how we can use that. So this question says, given that sine 30 is 1/2, which hopefully we know anyway, work out the length of AB, and AB is this side here. So let's label this triangle up. We've got the opposite, we've got the hypotenuse, which it's asking us to look for, and this is our adjacent again. Now again, we're not going to use the adjacent here, we're just going to use O and H. And if we remember our little formula, look, SOH has the O and the H in, and we're looking for the hypotenuse. There we go. So if we're looking for the hypotenuse, we cover up the H and we need to do O divided by S. So S is my sine 30, so if I was to do this on a calculator, I'd have to do 4, and I'd have to divide it by sine 30. Okay, but this question's actually told us that sine 30 equals 1/2, so actually what I'm doing is 4 divided by 1/2. I'll write that as a decimal, it makes it a little bit nicer to see, but 4 divided by 0.5. So actually it's just asking me to do a number sum there, which is 4 divided by 1/2, and if you divide by 1/2, it doubles the answer there, doubles the number. So 4 divided by 1/2 is 8, so my answer would be 8 centimetres. There we go. And of course that could go the other way around as well. I could have to do a times. So had it not given me this 4 here, maybe it had already told me that this was 8. Then instead I would do 8 times 1/2, doing S times H, so 8 times 1/2, and that would give me the 4 here that's been given as the opposite. So we could have it either way.